All right. I'll get started right away. But yeah, thank you so much for coming and listening to my talk today. It's a topic that I never really imagined that I'd be doing a talk on. So I'm excited to go over some of this stuff and hopefully give some previews of upcoming support for code coverage in Scala 3, and then also help kind of everybody understand a little bit just how your code coverage tooling works. But just a little bit about me. I come from like a non-traditional background into programming. I switched careers into programming. So I studied international relations in uni and then came into programming. I really enjoy simple tech. I am a big NeoVim fan. You'll find me working in like Scala tooling related things. I'm one of the maintainers of Metals, and I've wrote the Vim extensions for Metals, and yeah, I'm a maintainer of Scoverage as well. And I work in a like slew of tooling related Scala areas. I also host a Tooling Talks podcast, which, as you can imagine, is a podcast on tooling, primarily in the Scala ecosystem. I'm a software engineer at Lunatech, and the talk that I'm giving today, you can actually find on my website listed there, as well as other talks and links to pretty much like my social media accounts and other things like Twitch as well, because I actually stream often. And a lot of the stuff I'm going to be talking about today, I actually did on stream. So you could have watched me do it. But today I want to talk about Scoverage. And if you are unfamiliar with Scoverage, it's a code coverage tool for Scala. This is kind of crazy when I looked it up. And to be honest, I've like never spoken with any of these people that are like the foundation of Scoverage. But this is what I could find out from looking through stuff. But Scoverage was started already in 2010 by Mikko Kopinen. Then it was maintained for years by Steven Samuel and Grzegorz Slowakowski. There's over 1.5 million downloads a month, and it supports SBT, Gradle, Mill, Maven. There's even stuff for Pants and a couple other build tools as well that are built in. But it's sort of, you could say, like the de facto standard for Scala test coverage. And you might be asking yourself at this point, well, okay, how do you fit into the picture of this thing? And to be very, very honest, I write Scala and I needed code coverage for the job that I do. And it was not being continuously published for every Scala version that was coming out. And we were at work and we needed to update and it wasn't available. And I don't like not updating. So I just decided to adopt it basically and reached out and was incredibly surprised at how responsive the previous maintainers were. And they sort of just handed me the keys of the kingdom in some ways. So then that's how I got involved in Scoverage. One of the things you may be asking yourself related to that is even like, how does it even work? And to be honest, this was my first question when I got involved with Scoverage. I had used Scoverage for years and then like never thought about how it actually works. So when I had to do some maintenance on it and release it, I needed to like dive into it, obviously, to see how it works. So that's what I want to do today is I want to do a short overview of how this thing works in general, and then go into how it will work for Scala 3. So for Scala 2, this is a compiler plugin, Scoverages, and we're not going to do like a very deep dive into compiler plugins. There's like tons of other great resources on that. But just to name a few, if you are unfamiliar with how compiler plugins work or want to learn more about it, there's the plugin overview page in the Scala docs, which is really good. There's a video from Seth Tissue called Scala Compiler Plugins 101, which is exactly what it tells you exactly what it is. And then there's a really great video as well for Scala 3 called the Compiler Plugin Development in Scala 3. And it was part of the Let's Talk About Scala 3 series. So those are 3 great resources to learn a little bit more about compiler plugins. But to give you like a very brief introduction of what we'll be talking about, if you had a Scala 2 project and you wanted to see how a Scala plugin was being used, you could do something like this, which is what we'll do a little bit later in live coding. But if you had a project that you turned coverage on, and then you did a show, compile Scala C options, you'd be able to see this little X plugin, my path to the plugin, and then you have a jar. And that's the way basically that you tell the compiler, hey, we have a compiler plugin that we're giving you. And then you have a few other things that you can give it that are related to the plugin. So for Scoverage, that example, a couple of examples are you hand in the data directory, your source root, which is new to the like milestone releases, and then also maybe another setting like Scoverage has this thing where you can report the test name as well. So this is how you would include a plugin into your build. So, okay, that doesn't tell you a whole lot. It tells you how to include it, but how does this work internally? So, and the best way I think to explain this is just to illustrate it with like a very simple piece of code. So here we have a method is2, which takes in ints, returns Boolean, and does exactly what you would expect it to. It checks if the number is 2, true, else it returns false, okay? So this is the code that we are working with. In the compiler plugin, the main thing that it does is it will take the AST of your file, basically, and it will traverse that AST, and it will look for different types of trees in that AST that it wants to instrument, and what that means is basically it wants to wrap some code around it, which will call out to a method to keep track of what is being hit. So in this example, like again, give you one more look, we'll focus on the if part of this, right? So this if would fall into this case, and we would basically try to copy that if tree, and we would instrument different parts of it. First, you see that we are passing in the tree that we want to copy, which is I, and then we are processing the condition. So if you, like, we don't have nearly enough space on the screen to show this, but like pretend this case is part of a very large process method. So the condition, we are just recursively sort of giving it, and we're going to process this condition, and then that condition is some other type of tree that is going to be handled and potentially instrumented. So we'll forget about the condition for now. But two other parts that we're going to instrument are basically everything that falls into the then part of the statement, then also the else part of this statement. And not only that, but we are going to then again process what's inside of that. So to kind of illustrate what I'm saying, because I feel like it's a little bit maybe hard to like explain this and clearly follow it, is you can look at what this looks like when it's actually instrumented. It looks something like this. So here is your if is2 method. And again, you see at the top, you have your if, and you see the condition, which is wrapped in this, it's instrumented, we'll say, which is wrapped in a call out to the invoker. And that's how you know if the condition is ever covered in your tests. Then we have the then branch that would fall into. So there's one call there. Then we have a string literal. Like this is a very like simple example, obviously. So we're just dealing with a literal. So we not only are instrumented the then part of the if, but also the literal as well, and pretend that could be some other computation too. And the same thing for the else. So for like a very simple if expression here, you can see that there's 1, 2, 3, 4, 5 different parts of this code that is instrumented that could all show unique coverage of whether or not it's covered or not. And this is literally what your code would look like after it has gone through this process method in the compiler plugin. And while it's doing this, one other thing it does is it will create what's called an scoverage.coverage file. So if you ever, let's say we have a project with the module A, if you would look into A, target, whatever Scala version you're using, you'll see this directory called scoverage data. And inside of that directory, you'll see a file that looks just like this, scoverage.coverage. And it will have a header, which I've cut off here, but I put it to the side to like help you see what these are. But it has like an ID, a source path, package, like what the package name is, what the class name is, what type of class it is, the full class name, method, positions, the symbol, all that kind of stuff, just so we can keep track of every part of your code that is instrumented. So again, just to like do the entire part of this, you can see that this is actually the condition, because you can see it, we have an apply, number equals 2. So like that's the condition part of it that was instrumented is what we're looking at here. So you may be wondering at this point, because I said invoker a couple different times, what is an invoker? And an invoker is something that basically writes the IDs that call out to it, and it keeps track of how many times they are called, and then also can add the test name where it was triggered. So, and what I mean by IDs, again, is if we go all the way back over here, you see every one of these has an ID that corresponds to the ID, which is located in the first part of this. And then when this is actually triggered, it would write that out by the invoker does that. And what that looks like is another file in the scoverage data directory called scoverage.measurements. And here you can see that the IDs that were hit were 1, 9, 4, 8, and 7, and they were all hit from the same spec. So we know then that these are the IDs that were triggered by or hit by your coverage, and we could map those back to this scoverage.coverage file to get all the information about it. After we have that, we're then able to produce reports. And this is the part that as a user, you probably are used to seeing is just the report. We have a couple packages, we have some branch coverage, some statement coverage, and you could click in and you can see all of the statements and which ones are covered, which ones aren't, what package they're part of, all of that jazz. So this is sort of the end result that most people are used to seeing. And in general, like that's how your code coverage basically works. So, but we are here to talk about Scala 3 code coverage. So you might be thinking to yourself, okay, great. You just explained it all. Why not just like cross-publish it and call it a day? And we have Scala 3 code coverage. And that would be amazing if it worked like that, but it doesn't exactly work like that for a couple of different reasons. One of them is that we have a new compiler with new rules. So the compiler API is completely different in Scala 3 because it's a different compiler. So like many of the tools, and I think sometimes people sort of forget about this, and they wonder, why is tooling support not exactly where it's at for Scala 3 as what it was for Scala 2? Couldn't they just like cross-publish and call it a day? But the compiler is completely different. So much of the work needed to be redone. So similar to compiler plugins, some of them needed to be completely redone. There's also a 6-week release cycle. And if you have ever published a compiler plugin, you need to publish it for every single version of Scala that is published that you want to support. So for an example, like here you see my matrix that I currently publish for S coverage in 2.12 and 2.13. So there's there's 15 Scala versions that I'm already publishing for that you test on multiple JVM versions. So your test matrix is just gigantic, which is fine. But you can imagine if you're publishing every 6 weeks for a new Scala 3 version, your build matrix starts to just look ridiculous. And nobody wants to really deal with that. So the question sort of then becomes, well, what if we put it in the compiler? And this is sort of similar to how semantic DB was done. So if you're familiar with semantic DB at all, or you just watched Tomek's talk where he talked about how Metals uses semantic DB, and there's other tools that use it as well, that was actually inlined into the Scala 3 compiler, so it can natively produce semantic DB instead of having to have a compiler plugin that produces semantic DB. There's a lot of benefits to doing this. You don't need to release every 6 weeks. There's no, oh, I want to update, but I can't because I'm waiting for this other library to publish. This is especially relevant for things like compiler plugins that you have to publish for every single release. You can much more easily catch regressions. Like if something changes in the language and it's published, you can catch it before it's published, basically. Plus, you have a friendly group of compiler devs looking it over for you and giving you feedback on your code instead of just like randomly doing it on your own. If you're like me at all, like doing compiler type work is not something I was used to at all. So yeah, dealing with these ASTs and the presentation compiler and compiler trees, it takes a while to get used to it. Plus, the great part of all this was that Quentin, who was a student at EPFL a few years ago, already had a working POC for this like 4 years ago, and you can see the GitHub link to it. And this POC has just been like sitting there for 4 years, and nobody has really picked it up and brought it across the finish line. So I actually had no intention to work on this. I sort of was I'll take care of S coverage and just cut releases when we need them and then hands off. But yeah, one thing led to another, and like here I am giving this talk. So let's do this. So let's try to explain how this is done. And again, I want to say that like Quentin's work on this and the report that he wrote is incredibly useful. Most of the examples that I'm about to show you come from his paper, Code Coverage for Dotty. And there's a link here that you could even go read the paper if you want. So I want to be like very clear that I'm working just on the shoulders of other people here with this. So the first question is, where do we put this thing if it's going to go into the compiler? And I don't know if you've ever done this before, but you can pass in a .x show phases to the compiler, and you will see all the compiler phases. In Scala 3, the output is a little less pretty than it is in Scala 2, so it's sort of just like all out. But you may be wondering, okay, we're going to add a compiler phase. Where do we put this thing? So where it ends up going is right before the pickler phase. And that's right at the end of the front end phases. And it's important to do this before things like dead code elimination happen or other optimizations that would remove or change code that we want to instrument, especially if it's changing the positions of the code and adding things to your code. Then like you have to map stuff back to positions. It becomes sort of a nightmare. So this is sort of the easiest place to put it, to be able to instrument your code with the least amount of work and to accurately instrument the parts of your code that you actually want to instrument as well. And then when we talk about instrumenting parts of your code, there's different parts of tree instrumentation that you have to think about. And I'll give you some examples of those. So there's fully instrumented code. And these are things that can be fully instrumented just as they are. So in the example we looked at before with the if expression, there was one part in there that we just had like a literal, and there's nothing you like need to do with that. So we can simply just instrument that and rapid the tree, and that's it. That's all you need to do. Same thing with new, this, super, and certain selects as well. We don't have to do anything extra. We can just instrument them right as they are. And these are the easiest ones to deal with. Then you have certain things that you shouldn't instrument. And these are things that either their syntax don't allow it or the code may be just removed during compilation. So you can think of like imports as this, and then certain like wildcard identifiers, some annotations, no symbols, things like that just don't make any sense to instrument. We simply just return the tree and move on. We don't do anything with those. And then probably the most interesting part of this is partially instrumented stuff. And these are cases where we don't want to instrument the entire tree. So we sort of need to break the tree apart a little bit, figure out what part we want to instrument, and only instrument those. And the case def is a good example of this, where you can see that certain parts of the tree, like the pattern here, we're doing nothing with, but we are transforming the guard and the body, and that's it. So those two parts of the tree are being transformed and instrumented, where the other parts of the case def aren't being instrumented. And there are some other specific considerations that we need to make for these as well. And one of these we can look at with an example. So let's say we have a method or function that just takes in 3 parameters, A, B, and C. And it's part of main. And if you look at the call site of this on line 5, we call our function with 1, this throws, and some other computation. And think about it this way, where this throws does exactly what it says. It's going to throw. So ideally, if that throws, you don't really want to instrument, or it's not that you don't want to instrument, you don't want to say that our function is actually covered, because the apply of our function isn't really fully covered if this throws and the apply is never really called, right? So if you're thinking about it in terms of what part of this is instrumented and what part of this isn't instrumented, on the bottom line with the red and green, you can kind of see this, right? Main, we're reaching into main to get our function. So like that's covered. The apply on our function is not really covered. One is just a literal, so that's covered, like right away we know. This throws we called because it will throw, but then some other computation is not called. But then this gets a little bit tricky when you think about how you would actually implement this to make sure that the coverage is shown in this exact way. And we can do that with argument lifting. So this is actually reusing some of the same logic that is used during ETA expansion. So if you look at this, you kind of see the XO through X3 being lifted out of that. So the main is being lifted out, the literal is being lifted out, this throws, and then some other computation. So when we try to compute x2 here, and this throws, we can, stop. And we know then that x3 is not called. And then we also know that our function is never called. The apply is never called here. So this allows us then to more accurately know in this expression what part of it is actually covered in our code coverage and what part of it is not, if you had a test that was actually calling our function with this throws. Hope that makes sense. But you need to be careful where you apply this, because there are situations where you don't want to lift. And an example of this is like a Boolean short circuit here. So you can see on line 3, for example, if we were to lift out do thing, it would show that do thing was called and would be green in your code coverage, even though it's basically impossible to ever get to that point. So this is an example of a place we wouldn't want to do this. And there's special logic that we have in the process method that would make sure that this is not lifted here. Okay. So now that we have an idea of how this works in Scala 2 with the compiler plugin, we have an idea of more or less how this is done in Scala 3 as a compiler phase, where it's located, what it's doing, what are the different types of tree instrumentations that it has. The next question you probably have is, what can we reuse from Scoverage? Because it's already an existing tool, it works, great. And we run into some issues kind of with this as well. So let's go back to Scala 2. So Scala 2 Scoverage is made of 2 parts. We have a compiler plugin, which literally does everything. Like, it's the compiler plugin that handles like the traversing of the tree. It handles serialization to disk. It handles deserialization. It handles aggregation, and even handles your reporting, your XML writing, everything. Like, everything is just there. And then we have the invoker, which is used during runtime, and it's just one file. That's all it is. So as you can imagine, if we wanted to reuse a lot of this stuff, we would need to do some major refactoring. And that's what ended up having to happen, which ended up taking way more time than I had originally thought it was going to take. It ended up being more work than the Scala 3 part of it was so far anyways. So we have this compiler plugin, and we had to strip out the domain because we want to be able to share as much as possible these domain classes, because whether it was Scala 2 being written to disk or Scala 3 coverage being written to disk, when we read it up, we want some type of shared format that both can share. The serializer, I say serializer, but really the part that we can share is the deserialization part, where we're taking this coverage and the coverage measurements and deserializing them into our domain classes. So reading it up, whether it's coming from Scala 3 or Scala 2, can be shared. It's the same exact format. They share a format there. And then also all of the reporting that is writing your XML reports, your Cobero reports, your HTML reports, all that can be shared as well. So this ended up being a process of just stripping out as much as we could. So then what we end up with is Scala 2 land, we have a compiler plugin and an invoker. In Scala 3 land, we have it's part of the compiler, but we also have an invoker. Then we have a deserializer that's shared in Scoverage, some domain classes that are shared, and the reporter is shared. And those 3 are all now published in 2.12, 2.13, and Scala 3. And another way to look at that, and to say it a different way, would be the unshared part of it is the instrumentation of your code, because that's dealing directly with the compiler, so it can't be shared. The invoker, which is also needs to be there during runtime, and it's just part of the compiler, so it wouldn't make a ton of sense to have all the instrumentation part of it be there during compilation, but the invoker not be it, because then you couldn't actually call out to anything and write without it being there, without it passing it into the compiler. And if we did it that way, then we would sort of defeat the purpose, because if we publish the invoker in the Scoverage repo, we would still need to publish it for every version of the compiler to make sure it's available. But then the shared stuff is deserializing, all the aggregation of your stuff, and the reporting of your stuff as well. So let's do a little demo to better understand what I was talking about, to see how it works maybe, and then we'll call it a day. So let's jump to the terminal. So here I have a Scala 2 project, which is very simple. if you were going to look at what the build file looks like, it's just a two project build. We have an A and we have a B, which has some library dependencies, and then an alias just to help, which we actually won't even use. But if I was to start SBT, and I'm curious, like how many people use Scoverage or not, but a lot of times you don't do these individual steps like this. You would always just have like an alias or do in CI this would happen, but I think this will help try to help understand what's going on behind the hood. So let's clean everything just to make sure we're working with a clean workspace. And if we would do a show compile Scala C options for this project, we would see that there's nothing set, right? You just see empty lists here, which is what you would expect. So, and also just to like give a heads up, this project is using the SBT Scoverage plugin, the milestone releases. So right now there's like the latest releases, which I think is 1.4.10, but then there's also this 2.0 milestone release series, which already has support for all of this stuff and the Scala 3 compiler as well, if you've published the Scala 3 compiler locally from my branch, which many people probably have not. But if you wanted to test it out, you could, and we'll go over that in a bit. So if we turn coverage on, you won't see a whole lot happen. But then if you do a show compile Scala C options one more time, you'll see that there's a whole bunch more stuff. And this should look familiar to what we talked about when I showed the examples. We have here we have the compiler plugin being passed in. This changed a little bit because one thing I mentioned earlier was typically compiler plugins are all self-contained. So if you have a compiler plugin, you package it in a jar, you say X plugin, and you give the path to your compiler plugin. But what happens if you need to split your compiler plugin apart and your compiler plugin needs to rely on other things as well because it's trying to share it with Scala 3? As far as I know, this probably isn't that common of a case because normally compiler plugins are pretty self-contained. So in my case with Scoverage, you see that I'm not just giving one path, but I'm actually putting together a path. Like I have, here's a colon, and then another one. So I'm giving it the compiler plugin itself, the domain, so it has the case classes that it needs, and then also the serializer, so it knows how to serialize. So there's actually 3 separate jars that I'm passing in for the compiler plugin. Then you see some compiler plugin specific settings like the data directory, which is where we're putting our coverage, the source root, and the reason that we're passing this in now, which is also new to the milestone releases, is so that relative paths are used in the actual coverage file instead of everything having to rely on absolute paths everywhere, which was kind of a mess. Well, it's easier in some ways, but then it leads to a mess in other places. So now that we have this plugin included, what we can do is just say test. And you'll see a couple things happening. First, your code is being compiled, which we see up here, compiling. And while it's compiling, you see that it's cleaning the data directory to make sure there's no leftover coverage stuff from before. Then we're beginning the coverage instrumentation, which is what I showed before as we're wrapping stuff in wrapping certain trees and instrumenting part of it. And then we write that instrumentation to file, which is the stuff that I showed you before. And then we do it both for the B target and the A target, because this is a project with 2 different targets, okay? And then our tests run, which one should produce some stuff. So let's take a look at this. So if you were following up to this point, you'll know that if I look into A target Scala 2.13, which is the version of Scala we're using, and we have this Scoverage data directory, I think this one, yeah. Scoverage data. We have a couple of things in here. We have the scoverage.coverage file, which is what we talked about before. So if we take a look at this, you'll see that there's the header, which we should recognize with the ID, source path, package name, class name, symbol, location, all that jazz. And here you see, so this was something in basic control structures.scala, package A, the class name, it was an object, the full class name. It looks to be like an if-else statement, and it looks to be the symbol that it's actually testing is like less than here. So, and there's an apply in here, and you kind of see, and then you can see everything in the file. The other file that we have in here is the Scoverage measurements file. And this is just every ID that was hit again and the file that it was called from. So we know that 19487, exactly like the example that we showed before, was called during this, and the spec file that called it was basic control spec. Okay, so now if we keep in mind we have an A and a B that both produce these, but let's try to combine them together. So we can do a coverage aggregate. Now this will aggregate them together. This is a project I don't have very much coverage in, so that they're very low. But now if we get out of A and we go to the root of the project into target, Scala 213, Scoverage report, now you see some reports. And we can do an open index.html, which now you see the code coverage stuff. We have A and we have a B. If we go into A, we see the A specific files. We can go into the file. We can see the parts of the code. Remember the first one that we saw instrumented, I mentioned was a less than. So like here you see it. It's the first thing that was instrumented here. We can see the statement list of all the stuff in here, kind of what you would expect. I would assume that if you use Scoverage, you've seen this before. And that's in Scala 2 land, okay? So let's pause at this point and jump to Scala 3. So here we have a Scala 3 project, and this is an actual project. So what I did is I took a library that was published for 3, which happened to be Pool Party, which is like a tpoolcat library, and I just modified it a little bit, which basically just put it to the version of Scala, which is published locally for me. And then I added the code coverage, the new milestone stuff in here. So if you're curious what this one looks like, it's a little bit more advanced, but you see the version of Scala that it's using is 3.12 RC1 bin snapshot, because that's what I published here. And then there's a whole bunch of extra settings. There's some stuff in here, and then another alias as well. And the plugin that I mentioned that we're using is just the Scoverage plugin that you see here, 200 milestone 3. So same thing. We'll start up SVT, which will take a second. And what we'll do is the same thing that we did before. So let's take a look at the Scala C options. So show, compile, Scala C options. Here you see, apart from the JS cross stuff, nothing. There's nothing in Pool Party JVM, and there's nothing in like the root project. They're empty. So let's clean everything just to make sure we're dealing with clean stuff. Now, if we turn on coverage, something a little bit different will happen here because we're in Scala 3 land. So if we do a compile Scala C options now, what you will see is that instead of us passing in X plugin and a small little path to a jar or jars, you simply see this flag coverage, and you see a path here, which is the path that we're giving it to say, this is where you should put your data directory. This is where you put your stuff. And you can pass in a source root as well, but we can also let the compiler infer that, which will work for the vast majority of the time. So I'm going to just run the JVM test for now because I have some weird Scala.js stuff happening locally for some reason. So we'll focus on JVM, and coverage is turned on now, so we can just run test. And you'll see some warnings here, which is fine because I purposely have some extra logging turned on in the compiler that will log out parts of the compiler tree which are not covered at the moment. So that's why you saw this big thing here. So for example, unmatched type definition. So the tree, this type of tree, type def, isn't being caught. So that means either it's not being instrumented, which can be fine, right? Like some stuff we don't want to instrument. So maybe we're just passing it on. But there are some cases where we do want to catch these. So this is, again, the only reason this is on is just for me to be able to double check quickly, like what things are being skipped and really should they be being skipped. So the tests ran just like normal. And if we do the same thing that we did in Scala 2 land, so we can go into JVM, target, Scala 3.12 snapshot, we will have this Scoverage data directory. Now we have a whole bunch of stuff because this is like a real world project. So there's more stuff in here, right? So we can look into scoverage.coverage. And if you look in here, it should look exactly the same as it did in Scala 2. You have your headers, and then you have the location symbols and all of this stuff of everything that was instrumented in this project. The only difference was that instead of this being written from a compiler plugin, the compiler produced this natively. Same thing with this other stuff, these measurement files. Now we have a whole bunch of IDs, so we know all these IDs were hit during the tests. There's no test names because that's not implemented yet in the Scala 3 one, but we can still do a coverage report. We don't have to aggregate because we're not aggregating multiple stuff at the moment. You can see that the test coverage is quite a bit higher here, and now we can do coverage report, and we can do open the index.html. And now you see the same report that you saw before, except produced for a Scala 3 project. So let's take a look at one that's not 100%. So we can take a look at pooled resource, for example. You can see all of the parts of the code. So there's some pretty good test coverage in here, it seems like. There's a couple small things that are still red. And you can see the statement list of what things aren't covered, what types of trees they are, and the code that corresponds to these trees. So instead of just saying, okay, so it's an apply, that tells me nothing for the average user. So you can see, oh, well, it's the new apply partial with F, or you get to see more code. Sometimes they're really large, right? Like this apply applies to a whole bunch of real code, but it's just like one tree symbol. And that's kind of how it works. There are some things that aren't covered. Like I said, if you go back to where we did this compilation here, when it instrumented stuff, you do see that certain things aren't covered correctly. And there probably is more things to look at that need to be captured. So at this point, where are my slides? How to help if you're curious. So the first thing to do is, if you're interested in test coverage at all for Scala 3, please test this out. Yesterday, like my goal was to try to get a PR created by the time I did this talk. Like doing a talk was like the best way for me to like force me to get this finished. But you see there's a PR in Dotty now that's here with instructions of how to use this. So you could check out this branch, publish it locally. There's a couple example projects that I have here that all you need to do is, like I said, publish this version locally. Everything is set up in these projects and you can run it and see. Try to find parts of the code that you would expect to be covered or not covered and report back issues or even contribute them. There is also a ton of maintenance that is needed at this point. As I mentioned earlier, like the whole reason I got involved with Scoverage was because it wasn't really being maintained at the moment, which is totally fine. People move on, go to different ecosystems, do whatever. But it's a project that a lot of people use. So for example, there's a mill contrib module that's right in mill that we can use. There's the SBT Scoverage plugin. There's a Maven plugin, which is more or less abandoned. There's a Gradle Scoverage plugin, which is being actively worked on. And then there's a bunch of like example repos, and those are basically all abandoned as well. So my goal in being able to add support for Scala 3 is to both allow Scala 3 to have code coverage, but also to hopefully like help foster the community around Scoverage a little bit and try to get people interested and involved and hopefully revitalize the Scala coverage tooling, because it hasn't really been super worked on a lot. If you are a little bit more familiar with the other things that are going on or what's happening, I have another article here in the Scala C Scoverage repo where I sort of explain everything that I kind of talked about, what some of the breaking changes are, because when we were adding this, breaking everything apart basically just broke Scoverage for every single tool that uses it. And I realized that is not a small thing, but at the same time, there was no way to be able to support Scala 3 and Scala 2 without making some huge breaking changes. So the reason I say it's really helpful to try to help out the plugins is because all of these plugins will have to be basically redone, or not redone, I shouldn't say that. There'll need to be some changes in the plugins to account for the new structure. And there's also, I want to give one more shout out to this paper that Quentin wrote for university quite a few years ago, because it was incredibly helpful. It goes over all the examples that I gave, and it was the base of a lot of the work that I did. So without further ado, that is code coverage in Scala 3, what you can expect. And the PR is open, so now it's sort of iteration on the PR and hopefully get this merged in. So those of you that are on Scala 3 already can have working code coverage. And that's it.
Hi, Chris. Thank you
Hello.
so much.
Yeah.
It looks like we don't have any questions at this time, but I would love to invite you over to the Hop Inside. And if any questions come up, just give out the answers there.
Absolutely.
Oh, wait, sorry. Before I let you go here, it looks like we have one. So let's put that up on screen for you.
Okay.
All right. Are there any plans for integration with IDEs so that coverage can be displayed directly in the editor?
Yeah, that's a great question. Any active plans that are being worked on at the moment? Not that I am aware of at all. But if this is something you are interested in, it should be, I dare to say, somewhat straightforward. But the nice thing is that all of the information that you need is already written in these files, right? Like you have the start character and the end character. So it should be somewhat simple to read in these files and then be able to show them in your code, in your editor. It'll just take the people to basically add those integrations. So as far as I know, there's nothing that at least that I have any plans to work on or that is actively being worked on, but it's totally doable. Like that's something that's totally doable.
Fantastic. We actually had another question come in, so
Okay.
let's jump into that one too.
Yes.
Do you think it's a good idea to integrate Scala coverage compiler plugin for Scala 2 into compiler as well?
To be honest, I have never actually thought about it. I don't know. Scala 2 definitely, I would say, doesn't have the same push to try to inline as much stuff as possible, probably just because there's already things that are existing. The release cycle is much slower. Like we don't have releases every 6 weeks that we would need to keep up with. So I don't know at this point if the work would be worth it, because right now, when a new Scala 2 version comes out, it's sort of as simple as just adding it to the build matrix, making sure everything compiles and releasing, and then you have Scala 2 support. So I would not want to try to add a whole bunch of more work to try to inline it to the Scala 2 compiler as well. So good idea, maybe, if it was done like 10 years ago, but I don't know if it is today.
Totally understandable. Well, that is all the questions officially.
Okay,
we
thank
have.
you.
Thank you, Chris, so much for joining us, and I hope you get to enjoy the remaining day of the conference.
For sure. Thank you for having me.